Sorry. Okay, so again, this problem that we're looking at relates to the last homework question you had in the last assignment for section 2.2. In that problem, you had to show that an implicit solution of a differential equation was given by the log of x squared plus 10 plus the cosecant of y equals a constant. And you were able to show that. But then the problem said find the constant solutions, if any, that were lost in the solution of the differential equation. So what we're going to do is we're going to look at this differential equation, and we're going to find any constant solutions that were lost in the solution of the differential equation. Okay, so I'm trying to give you some understanding of that problem. So if we were to separate the variables, on this, we'd have the cosine of y over sine squared of y equals 2x over x squared plus 10 dx. Okay, we'd have this here. And then, of course, you can't have the sine of y cannot equal 0. That's important, right? And what I do on the left side of the integral is I make a substitution, u equals the sine of y. And then on the right side of that right integral, I let w equal x squared plus 10. Okay, and so you get the integral of 1 over u squared du equals integral of 1 over w dw. Okay, and you get here. So let me give you a moment to catch up here. Are there any questions so far? Okay, Zachary, hold on. The second line of the du. This is just, this here is du equals cosine of y dy. That's just the cosine of y dy. Hold on. Hold on, class. Okay, so Michael, just so I'm clear, this is the part that you're uncomfortable with. Is this right? This is the part that you're a little bit uncomfortable with. Okay, so you have the integral. You have the integral of the cosine of y divided, by the sine squared of y. Which is the sine of y squared, right? That's your integral. So you have to make a substitution. That's right, Michael. Excellent. It's a substitution. So of course the sine squared of y here, that just means the sine of y quantity squared. That's what that means. So I'm going to let u equal the sine of y. Then du is cosine of y dy, and du, yeah. And so now then that integral becomes this integral. What is after the cosine at the top? You mean, Matthew, in the integral? At the top of the page, hang on. It's the cosine of y. Cosine of y. Okay. Are there any other good questions? Okay, you're welcome. Michael, Zachary, are you comfortable? Zachary, you're good? Yeah, I guess I repeated the line twice. I guess I did it twice. So let me cross this out. Yeah, that's right. That's right. Okay, so let's make sure everybody's comfortable here. Absolutely, Zachary. Absolutely. Absolutely. I understand. Okay, so are there any questions so far up to here? Before I move on to the next page.
When you did the sine of y does not equal 0, would you have to do the same thing with the x squared plus 10?
Well, good question, Paige. Will x squared plus 10 ever equal 0?
Nope.
No. X squared's always good, Michael. X squared's always positive. Good, Ann. So, and good question, Paige. So we don't have to worry about the denominator on the right. It's just on the left we have to worry about. Okay. Are there any other good questions? That's right, Michael. All right. And of course I made a substitution, w equals x squared plus 10 on the right here. Let me know when we're ready to move to the next page. Okay, thank you, Matthew. Thank you, Ann. Okay, so now we have this integral here. We have this integral, right? That's nothing there. So let's go to the next page. And we will integrate both sides. Okay, and I'll let you write some steps down here.
Professor, I have a question.
Yes, Antonio.
Where or how do we get rid of the absolute value when we're changing from the 1 over sine to cosecant?
Oh, well, okay, the x squared plus 10 here is always positive. So that allows you to drop the absolute value.
Okay, that makes sense.
Okay, no problem. Okay, so now you have here -1 over the sine of y. Okay, thank you, Michael. -1 over the sine of y is negative cosecant of y by definition. And what I do is I bring the C1 over to the left side and call it negative C1 is just equal to C. And then I bring the cosecant of y over to the right side. And so you're going to get the log of x squared plus 10 plus cosecant of y equals a constant. And that's the, remember, how many recall that that was the implicit solution that you saw in that particular problem from section 2.2? How many recall that, or does that ring a bell? I mean, they gave you the implicit solution. They gave it to you, but how many recall that from that problem? It was okay, Matthew vaguely, Michael. All right. Well, now you know where they got it from. And what you're seeing here, is an example of where we solved a differential equation and got, I mean, this here is called an implicit solution because we're not writing y explicitly as a function of x. Okay, we're not writing y explicitly as a function of x. So it's an implicit solution. And generally, implicit solutions, explicit solutions are what we want. And in the homework, you've gotten mostly explicit solutions to your differential equations. But nevertheless, I wanted you to show you what an implicit solution is. But now, they ask about a lost solution in the problem. The lost solution is y equals k times pi. Okay, so in that problem, the very last, in the homework, the very last box, the answer you need to put in is k times pi, where k is an integer. That's your lost solution. And the reason, and so, you know, what happened, remember, is we divide, in this problem, we divided earlier on, when we separated the variables, we had a sine squared of y in the denominator. Well, that's the quantity sine of y squared, right? That was in the denominator. Of course, we couldn't allow the sine of y is not allowed to equal 0. Okay, so but it turns out that if you let y equals k times pi, it is a solution to the differential equation. Because if you take the derivative of k times pi, okay, if you take the derivative of k times pi, all right, hold on now, let me just check one thing on this. I want to make sure I'm being, yeah, because remember, dy dx was equal to 2x times sine squared of y divided by x squared plus 10 times the cosine of y. So if you substitute in k times pi for y, it's a solution because you get 0 equals 0. Okay, so that's the solution that was lost. That was the solution that was lost. It's a solution to the differential equation, but yet we don't see it in the implicit solution. We don't see it in the implicit solution. Okay, so that's what's called a lost solution. So what I'm doing here is I'm showing you that if we substitute, if we let y equals k times pi, okay, I mean this now, what I'm showing here is separate from the implicit solution. We found the implicit solution, but then, hey, what's the lost solution? The lost solution is y equals k times pi, where k is an integer. That's the lost solution, because based on this check here, it is a solution to the differential equation. It just doesn't show up as part of the implicit solution, because the implicit solution, to get that, we had to divide, well, in the implicit solution, we had to divide, to separate the variables, we had to divide both sides of the, of the differential equation by sine squared of y. And if y were equal to k times pi, that would make, the sine function is equal to 0 for integer multiples of pi, right? So that is what I wanted to show you. I'm always thinking about your future. What could you see in a future class? And if I can be as if I can show you as many, I like to try to show you different scenarios, so then you'll be better prepared when you move on in your coursework. You could see this in another course, for instance, this kind of situation, and now you've seen it here, and so you'll be better prepared in the future. Are there any questions on that? Okay. Thank you, Matthew. Thank you. All right, just one moment. Okay, question. So a lost solution is where something, Zachary's saying a lost solution is where something in the differential equation cannot equal a certain number, but works out when plugged in the equation. That's correct. That's correct, Zachary. That's absolutely correct. You see, if you look back to the original differential equation here, on the right-hand side, right? That's a y there. On the right-hand side, you have 2x times sine squared of y times x squared plus 10 over cosine of y. Okay, well, that right-hand side, well, I want to be a little bit careful here. It doesn't really relate to that. No, it doesn't relate to that. It relates to this step here, where we divided by the sine squared of y. So that excluded the possibility that k times pi could be a solution. For if we're going to solve it and get an implicit solution, k times pi would not be part of those solutions. But if we go and just look at the original differential equation, here, then k times pi is a solution, because you see, looking at the original, it's just like making a good guess. We made a good guess on the original differential equation, k times pi, and it worked. It's a solution. It's just not a solution that's in the set of this implicit solution set. That's all. Okay, Zachary, does that make good sense? Okay, excellent, excellent. All right, what I want to do, I want to do another problem with you, but this problem's from section 2.3. So I need to scan. Let me stop the recording. Are there any other questions?